Hey everyone, welcome back to the channel. Today we're diving into one of the most fundamental and honestly, one of the most beautiful algorithms in all of computer science, binary search. Now I know what you're thinking, algorithms sound scary, but I promise you, by the end of this video, not only will you fully understand binary search, you'll actually think it's kinda genius. And the best part? You don't need any coding experience to follow along. So grab a coffee, sit back, and let's break this down together, step by step, nice and easy. Real-world analogy. Before we even touch computers, let me give you a real-world example that you've probably done 1,000 times without even realizing it. Imagine I hand you a thick dictionary, like one of those old heavy ones with thousands of pages, and I say, find the word mountain. Now what do? Do you start from page 1 and go, page 1, page 2, page 3? No! That would take forever. Nobody does that. What you actually do is flip the book open somewhere in the middle. Maybe you land on the letter M. Now you think, okay, mountain starts with M and M is right here, so the word is somewhere close. You flip a little forward, then a little back, narrowing it down each time until, boom, boing, there it is, mountain. That instinct you just used? That is binary search. You didn't search everything. You kept cutting the problem in half. That's the entire idea, and it's incredibly powerful. What is binary search? Okay, so let's bring this into the world of computers and data. Binary search is an algorithm, which is just a fancy word for a step-by-step set of instructions that finds a specific item inside a sorted list super efficiently. The keyword there is sorted. We'll come back to why that matters in a second. Here's the basic idea. Say you have a list of numbers 1, 3, 7, 12, 19, 24, 38, 45, 56, 72, and you're looking for the number 38. Step 1, find the middle of the list. The middle here is 19. Step 2, ask yourself, is 38 bigger or smaller than 19? It's bigger. So we throw away the entire left side. We don't need 1, 3, 7, 12 anymore. Gone. Now we're left with 24, 38, 45, 56, 72. Step 3, find the new middle. That's 45. Is 38 bigger or smaller than 45? Smaller. So we throw away the right side. Now we have 24, 38 middle is 24. Is 38 bigger? Yes. Throw away the left. We're left with just 38. Found it. Done. In just 4 steps, we search through a list of 10 numbers. The power of binary search. Now here's where it gets really mind-blowing. Let's talk about what happens at scale. Imagine instead of 10 numbers, you have 1 million numbers in your list. 1 million. That's a lot. If you search through that list the old-fashioned way, starting from the beginning and checking one by one, in the worst case, you'd have to make 1 million checks. That's called linear search, and it's painfully slow for large datasets. But binary search? To search through 1 million items, you need at most just 20 steps. 20. Let that sink in for a second. 1 million items. 20 steps. How is that possible? Because every single step you take, you're not just eliminating one item, you're eliminating half of everything that's left. Half. Every single time. So you go from 1 million to 500,000 to 250,000 to 125,000, and within 20 steps, you've zeroed in on exactly what you're looking for. This is described in computer science as O log n, or logarithmic time, and it is one of the most efficient searching techniques ever discovered. How it works. Step by step. Let me walk you through the exact steps one more time, very clearly so it really sticks. Step 1. Start with a sorted list. This is non-negotiable. Binary search only works if your data is already in order. Smallest to largest, A to Z, whatever makes sense for your data. Step 2. Identify the middle element of the list. If the list has an even number of items, just pick either of the 2 middle ones. It doesn't matter much. Step 3. Compare your target, the thing you're looking for, to that middle element. Step 4. 3 things can happen here. If your target equals the middle element, congratulations, you found it. Stop. If your target is less than the middle element, ignore the right half entirely. Search only in the left half. If your target is greater than the middle element, ignore the left half. Search only in the right half. Step 5. Repeat steps 2 through 4 on your remaining half. Keep going until you either find your target or your list shrinks down to nothing, which means the item isn't there. That's it. That's the whole algorithm. Simple, elegant, and brutally efficient. The one big rule. Now I have to stress this one more time because it's the most common mistake beginners make. Binary search. Only works on a sorted list. If your data is random or unsorted, binary search will give you wrong answers or fail completely, because the whole logic depends on being able to say, My target is bigger than the middle, so it must be on the right side. That logic only holds if everything is in order. So before you ever use binary search, make sure your data is sorted first. Sort it. Then search it. In many real applications, data is already stored in sorted order for exactly this reason, so that searching is fast and reliable. Where is binary search used in real life? You might be wondering, okay, cool, but where does this actually show up in the real world? Honestly, everywhere. When you search for a contact in your phone, binary search style logic is at work. When a database looks up a record by ID, binary search. When you use git to find which code commit introduced a bug, there's literally a command called git bisect that uses binary search to find it. When you play a number guessing game, higher or lower, you're naturally doing binary search in your head. Even in medicine, dose-finding trials sometimes use binary search logic to find the right drug dosage efficiently. It's one of those foundational ideas that quietly powers so much of the technology we use every single day. Recap. Alright, let's bring it all together. Binary search is an algorithm that finds an item in a sorted list by repeatedly cutting the search space in half. It's incredibly fast. 1,000,000 items in just 20 steps. It only works on sorted data, and it's used everywhere, from databases to your phone contacts to software debugging. If you're just getting started with computer science or coding, binary search is one of the first algorithms you should truly understand. And now you do. If this video helped you, smash that like button, subscribe for more beginner-friendly CS content, and drop a comment below telling me which algorithm you want me to explain next. I'll see you in the next one.